So let's continue looking at these various basic semantics. So we've looked at logical ANDing, ORing. One other exception, or option we should say, is logical independence using semicolon. So command chaining using logical independence. So essentially, this format builds no dependency between the commands A and B, left and right, 1 and 2. So, for example, maybe we cat 1 through so on and so forth, and regardless of the output, we still LSL. Let's change the logical OR to semicolon. So essentially, run both A and B, regardless of, say, exit status of A, or perhaps we'll reword it as run B regardless of exit status of A. This is a logical independence because you may simply want to run a series of commands. So this runs a series of commands without any respect for the exit status of the previously executed command. So let's say we change this to semicolon. So we expect A to run, then B. That's fine, because A ran successfully, and B we expect to run successfully. Both are both valid commands. But even if we make it invalid, let's say we try to cat the contents again of 12.txt, which doesn't exist. Well, that'll fail. However, ls will still execute. That's the big difference, a logical independence. So irrespective of the output of this command, command A, if you will, or command left, or command 1, command 2, or right, or B will also execute. That's logical independence. Basically, a facility to execute a series of commands. So, the Bourne shell, as well as the bash shell and the corn shell, provide these facilities: logical ANDing, ORing, and other shells, and logical independence, as well as append redirection, output redirection. And most commands have standard input or input redirection, wired to usually mean a file or something, some series of data supplied by the keyboard on the command line via the mouse or some input device, etc. So other commands. Well, sometimes you want to see just a fraction of content, especially when dealing, let's say, with large textual files such as log files. So a couple of commands might be helpful for you, head as well as tail. So as their names imply, they reveal the head or the tail of content. So reveals, or they reveal, head or tail of content. And this can be quite useful when dealing with particular, or in particular with large files. So let's say we head var log messages. This will extract the first 10 lines. And normally we need to have the appropriate privileges, but that we can confirm using LSL, as it varies across distributions. So let's see what we've got. So yes, we need the right privileges here, so we'll sudo it. So the file, before we actually execute this, is 270,000 bytes. That's too much to fit within the confines of our terminal window. However, the first 10 lines, and if you pipe the output into WCL, you'll get a count, will fit, and will give us an idea of what happened first in this particular log file. And conversely, tail gives you the last 10. Take off WCL, and they're the most recent 10 entries. So, reveals first 10 entries. And conversely, tail gives you the last 10 entries. Perhaps tail is most important, or more important, of the two because it shows you the most recent activity, especially if you're trying to debug a recent activity. So, reveals last 10 entries. basic commands. What else is of interest? What about the type of file you're dealing with? So reveals the type of content a file is, i.e. PDF, text, binary, and so on, flash. So just point file to the file and let it do its work. So for example, this is what we have in temp. File star. These are all text files, ASCII text. What about binaries? What about file itself? File, which file, tells us that it's a binary, 64-bit base binary. What was this that we just performed, or what are these, backticks or special characters? Another shell semantic. So as an example, let's just include this, backticks. So exposes that file itself is of type binary, 64-bit base binary. That leads us to another thing. The shell provides us with backticks as a means with which to perform command substitution. So command substitution. And there are two ways, or two mechanisms. So using backticks or $ parentheses, close, open and close parentheses. So for example, this recent example of file, or file which file that is. So essentially what this does is it substitutes the output of which file as the input of file. So substitutes the output of essentially which file as the input to the file command. So what does that mean? Well, what happens when you execute which file? Well, which is a command, a W command, that tells you where a particular file can be found, or a particular executable script, text file, etc. So the output of which file is exactly what you see here, /user /bin /file. If this thing can then be supplied as input to the file command, then you can run a file against it, or anything against it for that matter. So command substitution takes the output of one command and serves it or supplies it as input to another command. And there are two different ways, or two syntactically correct methods for executing this. One is $ parentheses open, as we've mentioned, not curly braces but parentheses, and the other is using backticks. Either or works. So let's take this example. And this can be quite helpful because sometimes you need the output of a particular command to be served to the input of another command, for which there are different methods, of course, to pull that off, but this is just one way of doing it. This is quite useful, for example, if you're setting a variable. So you can say a variable is equal to command substitution. For example, let's say we export test1 equal to whatever it is we just did, which is which file, such that when you echo test1, it stores the contents of which file. So this becomes a variable that's useful. And for any command that supplies useful output, you can set it to a variable. So 22 set variable, shell variable that is, to the output of a command. And this would do that for you. So for the duration of that shell, so sets test1 for the duration of a single shell. And to prove this, if you Control-Shift-T a new shell, new 2ty, new pseudo terminal, for example, and try to echo test1, it's a variable that doesn't exist, it's empty. So it is tied to a particular shell, nor does it exist in the other spaces. So test1, it exists solely in this window, test1, and echo can reference it, or any other means of executing the bash environment can access that shell's, or that particular shell's variables. And there are all sorts of variables set. By the way, set tells you, as well as environment, the various variables that are set. So reveal let's say shell vars, and details using the following. Environment, that gives you a list of variables, and set, things that are set, including variables as well as options to variables and commands and so on and so forth. Some more commands, again in no particular order, just as they come to mind. So when the system boots, it essentially logs as much information about the environment, hardware detected, if any problems detected by the kernel, IP addresses set, storage found, so on and so forth. All that information is logged. Now, of course, it's in usually varlog messages, varlog, bootlog, etc. Different files in varlog. But one command helps you to get to that information concisely, and that's dmessage. This dumps the kernel boot messages. Sometimes if you just want to know how the system most recently instantiated itself, if any issues, any new hardware, so on and so forth, execute dmessage. And this will dump all of the hardware, everything that has been seen. Well, these are basically firewall rules that are being dumped, so that's taking up a lot of space. But if you look at it with less, which is one of the pages, you'll see how the system came up, CPUs, all hardware detected, any issues, and so on. Scroll through it. You can look for new issues, new hardware, anything that may have changed relative to your policies and so on and so forth. It's a good place to debug. So dmessage, kernel boot log, anything the kernel sees. And of course we dumped our output, that is, into less. Less is a pager, so less and more, or more and less, are paginators. Basically one page full of data at a time. So page full of data per dump, and it's tracked accordingly for you. Because again, the files are large, so sudo, let's say less varlog messages, well, this will give us one page full at a time, and we can look at it and digest it accordingly. Otherwise, it will almost always overrun the existing space. Other commands that come to mind. Process listing. One important utility is top. Top auto refreshes key stats. And you can tweak, of course, the frequency. But for example, it gives us memory utilization, CPU, top programs running, uptime, and other data. So if you just want to get a sense for how your system's performing, run top. Any user can interact with top. The process list is available to everyone. You're not able to kill other users' processes, but you can examine the processes that are running, which is why you should be careful about how you invoke processes on any NIC system, as credentials or confidential information is likely to be leaked by any user who has access to enumerate the process listing on the system. So be careful. However, notice it gives us useful information. Load average, that's something we should put in there. So load average, and we'll also include etc. CPU utilization, top programs that are running, who's running them, the amount of memory in use. So of the 1 gig, we're using almost 90% of it. How much swap, that's part of memory. We're using just a little bit of it, and so on and so forth. Another utility is PS. EF option, AUX option, displays the user, the PIDs, dependent PIDs, TTYs to which they're connected, the commands that were executed, how long they've been running, and so on. When your NIC system comes up, there are a series of PIDs that are unattached or detached from TTYs that are used to actually run the operating system. So you'll just see a question mark for those. So PS, let's say PSEF, AUX, however you choose to run it. So PSEF, or let's say AUX, returns PIDs, dependent PIDs, users, processes, TTYs, etc. And any user, as you've just seen, any user may interact with this process dump. So you need not have special privileges. You can trace the hierarchy, the dependencies of processes as they're executed. So if a shell is spawned and then spawns 10 instances, you can follow the trace. PS with no options shows you what's been executed in the current shell. So the PID for this shell is 36004. So if we PSEF grep 3600044, you'll see anything related to 044. So the user Linux CBT spawned pseudo terminal number 2, that's this window, on this PID, and then from there executed PSEF, and grep was also executed. This is an alias which auto-colors the matched items. So let's just say we take this command and include it as part of our item here. So B, PSEF, shows all PIDs related to PID equal to 36044. And PS by itself reveals the basics of processes, let's say launched in the current shell, which gives you a starting point with which to debug or find information, more information about the items that have been launched in the current shell. More commands. Let's say we open another spot here. So top gives us memory utilization as well, and it brings in or aggregates or incorporates or includes the output of the free command. Free reveals memory utilization, and in particular focuses on the key areas of memory, RAM as well as swap. And we tend to run it with the human readable option or the megabyte option, but you can run it however you see fit. So the mem line reflects the actual random access memory accessible to the system, and obviously the swap line reflects the disk-based memory. So have a look at this, but top aggregates this information as well. So you can use top as your one-stop shop for information about memory. Let's introduce another command, df. And this shows the mounted file systems and their, let's say, related storage usage. So human readable format H is probably the best option. So this shows us the mounts. Now, since we're using this version of SUSE, which uses btrfs, we're going to see many more mounts than we typically see on older versions of SUSE and other versions of Linux. If you're accustomed to Solaris with ZFS, then having so many quote-unquote file systems present may not be a surprise, or mount points, if you will. And you have to get over seeing the same amount of storage for all of those points, because they're all referencing the same storage backing, which is a root file system, in this case dev SDA2. But beyond that, you see the size, the availability, the usage, and where it's mounted. So that's good information. And similar to that is the mount command. Mount command gives you details about the file system, the options that are used to mount it, so on and so forth. So let's just include as part of this df as well as mount. So B mount reveals mounts and options associated. Why is that useful? Well, to tell you exactly how a particular mount point has been mounted. Is it read-only, read-write, so on and so forth. Any particular permissions associated with it, mount will give you that information. df gives you more DU or utilization type information. Mount gives you the metadata, the specs that were used to mount a given mount point, the options that were used to mount or to make a particular mount available, whereas df gives you utilization information. So two different commands for accessing information about mounts. And there are tons of other commands. The commands really never end. They go on and on and on. For example, let's say you need to generate data. dd is one such command. Actually, dd can be used to duplicate any data that's readable by your NIC system. So, can duplicate any accessible data. Anything really. Any type of format. So any format. ISO, binary, text, doesn't matter. Normally you supply dd with an input file, and you give it an output file. And oftentimes you use counts and sizes, byte sizes, etc. But it's useful perhaps in just generating dummy data. And we like to use dev0, and you'll see countless references to this usage online. So if you use a dummy source such as dev0, but you could use anything as a source actually, and you can replicate it, so it's a duplicator. So let's say you have a file with 10 bytes. Well, you can take it and replicate it 1,000,000 times and end up with 10 million bytes. So if you use a dummy source such as dev0, you can quickly create a file for any sort of usage, perhaps for file transfer uses, which is what we tend to do with Linux CPT. We create a dummy file and then move it around and see how fast and how well it moves and so on. So let's say the output file is going to be 1 GB. Byte size 1 megabyte. Count 1,000 of these, or 1024 of them, since 1,000 really doesn't exist on a binary system. So this will create some file called 1 GB using byte sizes of 1 megabyte chunks, and it'll do so 1,024 times. So it duplicates whatever information, whatever input you give it, 1,024 times in 1 megabyte increments. Well, let's make sure we have enough space. So DFH, and we should have enough space available, 15 gigabytes. We're currently in the home space, which is under root. So this is home, dev SDA2, which is really root. So this will use that as an input for source, an input file or an input source, and write the content to some file somewhere. And now you look at the file, it's a gig. So just like that, we have a gig of dummy data filed against it. It tells us it's data. It's not usable. It's not intelligible. But just as easily, you could have dd read any content and replicate it as much as you want. So there are many such commands like these that are useful, that are considered critical. We'll be looking at some more. We're looking at, for example, compression tools, client tools such as DNS, netstat, so on and so forth. All those are important. They help us to do different things, communicate in different ways, and they're standard across distributions. So let's move on.